friends, today we'll be discussing how to traverse a tree when it is viewed from the top view, and mainly we'll be able to see the nodes which are externally present. So in this case it will be 1, 2, 3, 4 and 6. These are the nodes that will be visible, and one of the main concepts for solving this problem is we need to traverse it level wise, that is a level order traversal. You can have a look at the video which has been posted earlier, and then we need to mark the distance. The Since the root node here, we will mark the distances of each nodes from the root node. So the value for root node will be 0, and then whenever we move to its left we'll add -1. If we move to right we'll add +1. So for this particular node we'll add 0, -1, which is -1. The distance will be -1. For this particular node it will be -1, -1, which will be -2. Similarly for 3 and 6 we'll get values as 1 and 2, and for 5 -1 plus 1 will become 0. So since we'll be visiting this no, we would have visited this node earlier, we won't be considering this node. We'll now take a look at the exact approach for this problem. First we'll insert the root node. We'll consider the root node and then check the distance, check its distance from itself, which is 0, and since 0 as a key does not have any value yet in the hash map, so we'll proceed and add the value into the hash map. So 0 is the distance and 1 is the node value. Then we add the child nodes for the node under consideration. So we'll add these child nodes in the queue behind 1. So once these child nodes have been added, then we'll again consider if 2, what is the distance from the center, that is the root node. So the distance is -1, and -1 key doesn't has any value yet in the hash map table, so we'll proceed and add it. As long as the key doesn't exist, we'll be adding it to the hash map. Then when added as left node and a right node, we'll add again the child nodes to the end of the queue, and then proceed to check if 3, what is the distance of 3 from the root node, which happens to be again 0 plus 1, which is 1, and 1 doesn't has any value, so we'll be able to add it. And then we again check for the child nodes of 3, and since 3 has one child node, so we'll add it to the end of queue, and then we thereby complete the traversal for the second level, and now we start traversing for the third level. Again we check if node 4, the distance, what is the distance from the root node, which happens to be -2, and since it is -2, so -2 is not yet inserted into the hash map, so we'll proceed to add this particular node. After that for 5, the distance will be -1 plus 1, which happens to be 0, and since 0 is already existing, this won't get added into the hash map. And for node 6, it's at a distance of 2, and 2 is not yet added into the hash map, so we'll consider it. And then we proceed to check if any of these this particular level nodes have any child nodes. None of them have it, so thereby we obtain our hash map, which can we can then read the values of each and every key and add it to our result array. Better understanding, let us translate this entire thing into a code. Okay, so let us have a look at the logic. First we add the root node, which is in this case 1. So we'll add 1, 0 to the queue in the beginning, and then start reading the elements that are present in the queue. So first we'll be polling and obtaining our first node, and its distance is 0 and its node under consideration is 1, then since there is no such key, 0 is still not added into the map, so we'll be adding it and then checking for its child nodes. So in this case, the to the left of 1 is 2 and to the right of 1 is 3. So here we can add 2 comma hd is that is the horizontal distance is still 0, so 0 minus 1 will be minus 1, and the to the right of root node is 3, so 3 comma 1. So that's how we'll add, and then this will iteratively keep on traversing the entire tree until it obtains the top view of the tree. So the code is available in the link given below. Hope you have understood the top view traversal of a tree. Thank you.